All right, so this is the second part of the video that goes with the notes, since we can only do about 15-minute clips. If we were doing this in class, this is the time I would ask you to get with your partner and try it on your own. So why don't you guys try this on your own, hit pause on your video, right? You should have enough information that you should be able to do something like this on your own. And then after you're done, go ahead and hit play again so that you can check to see if your work matches my work. All right, so checking your work, making sure that everything's okay. Your final graph should look like that. If you didn't get that, see if you can figure out through comparison what went wrong. Okay, if you can't figure that out, then stay tuned for work, because I'm going to work it out completely next. If you did fine, you can skip on to problem number 6. All right, so if you're having trouble with number 5 and you didn't get it on your own, right, normally we check to see if the bottom or the top can be factored, and this one's actually already factored for us, so we're going to continue on to the ready process. So the roots is when I set the top equal to 0, but 2 cannot be 0, so that means we have no roots. Next, I'm checking for asymptotes. This is when I set the bottom equal to 0, and I have 2 factors that I have to set equal to 0. So when I set this one equal to 0, I get a vertical asymptote at x equals -3, and this one gives me a vertical asymptote at x equals 1. The next step in the process is my t's. T underneath the r is talking about, is the root tangent? To figure that out, you need to look at the top, right, and see if this is a squared, but remember we didn't have any roots, so that means I can't have a tangent root. Then when I talk about t's for asymptotes, I need a t for each asymptote, right? This t stands for together or not together, right? So do they look like a reflection across the asymptote, or are they having opposite behaviors? So to see if which one it is, you look at the bottom, because that's how we derived our asymptotes, by looking at the bottom. We're looking for if any of the factors are squares, and neither one of them are squares, so I'm going to write not on each one. So when I go over here to draw in my vertical asymptotes, right, at -3, right, I'm going to put a not on top of it to remind myself later on when I'm trying to piece everything together that we are not together there. And then same thing over here for x equals 1 for this asymptote. Don't forget to label it. We're going to have a big not on top to remind us that they will have opposite behaviors on either side of the vertical asymptote. Remember, if you like highlighting your asymptotes to remind yourself you're not allowed to cross or touch, right, you can do that. All right, E for end behavior. We get that by looking at my first terms. The bottom is factored though, so I don't technically have a first term yet. But remember, to get the first term, what you would do is distribute everything out, multiply it out, or FOIL. And to get the first term, it's always f, the f step. So the f step gives me x squared. The first term would be x squared if I FOIL everything out. We're going to skip the O, the I, and the L because I don't need the other terms. So we take the ratio of the top term, first term, and the bottom first term, and I get 2 over x squared. This is bottom heavy. I can't simplify anything. It's bottom heavy, right? So that means y equals 0 is a end behavior that's happening. So I'm going to put some crosshairs this way, label y equals 0 here. That my end behavior of the graphs must be approaching 0. Also, because it's bottom heavy, I can also draw in some end behavior arrows already, because this looks like the rational squared function, and it's positive. I know that my end behaviors have to be above the x-axis. The y in radi stands for y-intercept. Remember, we can get this by substituting in 0 for your x's, right? So it's going to be a point, right? I'm plugging in 0 here and here, and I get back -2/3. All right, so we're going to label that 0.2. there's all the pieces that I have to my puzzle, and now I just got to think about putting it all together. So starting at the left, I have an arrow, right? I've got to work with this arrow. This arrow, remember, I can't be crossing over the X because that would create another root. So it must be going up towards the asymptote. If this arrow's up and this asymptote says not same behavior, then this other arrow must be a downward facing arrow. I have to pass through this y-intercept, but I'm not allowed to touch the x-axis. So what that means is I must be turning and being pulled towards this asymptote now. This asymptote has not the same behavior. So if this arrow is down, then this arrow must be up, and I'm going to connect this arrow with my end behavior arrow. All right, so we're back together now with our last example. This one, when I'm looking at it, I'm going to check to see if I can factor some things, right? On the top, I can factor it to x minus 2, x plus 1, and on bottom, I can factor it to x minus 1 and another x minus 1, which means it's really x minus 1 quantity squared. Okay, we're going to check radi, right? We're going to do our radi steps. I just want to clarify that some of you guys might be thinking we can cancel something here, but remember the signs are different, so you're not allowed to cancel there. All right, so doing the radi process, right? R's for roots, it's when the top is equal to 0. So if I set x minus 2 equal to 0 and x minus 1 equal to 0, I get back that this one gives me 2. This one is a 1. So this time I have, oh, excuse me, this is a plus 1. Right, this is a plus 1. So x plus 1 equals 0 gives back a negative 1. All right, so these are my roots. So we're going to mark off 2, 0, and negative 1, 0. We're going to label our points. Moving on to the A step, this is when I set the bottom equal to 0. Right, so I'm going to set x minus 1 quantity squared equals 0. This happens when x equals 1. Right, so over here I'm going to draw in a vertical asymptote. X equals 1. I'm going to highlight it to remind myself I'm not allowed to cross it. Okay, from there, what I'm going to do is the next letter T. T is checking for tangent on the R. Are any of my factors above squared? The answer is no. So that means for both T's, the T on this root and this root, they're crossing, not bouncing a tangent. This one is talking about my asymptote, the bottom, and it is a squared factor. So this means on either side of my vertical asymptote, they have the same behavior. They are coming together. So I'm going to put TOG to remind myself together at that asymptote. Next is E, end behavior. End behavior is when we compare the ratio of the first terms, right? So we've got y equals x squared over x squared, which reduces to y equals 1. So end behavior is approaching y equals 1. Next is y-intercept. Y-intercept is when I substitute in a 0 for all the x's. So 0, 0, I get negative 2 on top, right? And on bottom, I get back 1, which is just negative 2, right? So we go over here and we plot that point, and we label it. All right, so now we have all the pieces of the puzzle together, all laid out for us, and now we just got to make it work. So we're going to start by working on the left, right? I know that this end behavior, right, is close to 1. but I got to connect to these points, so it must be like this. I have together here, so that means on the other side it looks the same, right? They're behaving the same way on either side of the asymptote. I have to go through this point and approach my other asymptote.